the first diagram, you can see the mold cavity, and this is the molding material. This hatched one, you can see two portions of molding. This left half is one piece, and right half is the another piece. These two pieces are assembled. These two pieces are assembled to get the cavity. See, this is the mold cavity. So they are properly fixed, assembled like this. So now what we are doing in this case of slush casting, so first it is kept in the upright position. Upright position. First both the pieces of the mold are assembled, and then it is firmly fixed so that it will not lose when the liquid metal is applied into it. So then after fixing these two properly, then the entire mold cavity is kept upright position. Upright position means like this. Okay. Then we are supplying the liquid metal into it. See the droplets, you can see that liquid metal filled into this. Okay, into the mold cavity. After filling the mold cavity with the liquid metal, so we will allow it for some time, very short period of time. We are allowing it. We are allowing the liquid metal to be there for short period of time. Then afterwards, what we are doing, we are pouring down the liquid metal again. See the mold cavity or molding box, it is inverted. It is inverted. When it is inverted, the liquid metal, excess liquid metal will be falling down through this mouth. Okay. What is happening here? A thin layer of metal was adhered to the surface of the mold cavity. This is the surface of the mold cavity. To the mold cavity surface, a thin layer of metal is adhered. Okay. Because we want a thin shell only. We want to make some hollow shape of casting, flask like that. So therefore, what we are doing, just we are filling the liquid metal into it and then allow it for some time. How much time it is required to allow? Depending upon the thickness of the metal here, the wall thickness, how much wall thickness you want. So depending upon that, we have to allow it. So longer the time, thickness will be more. Short time, thickness will be less. Like that, what we will do now. So first we fill the liquid metal. Before filling the metal, we have to treat this surface, mold surface, with a non-sticky, so that it should not stick. The liquid metal or any metal should not stick to the surface. Easily it can be opened. So like that, some coating will be done on this surface. After that coating is over, then the liquid metal is supplied or filled. Allow it for some time so that solidification process begins at this. Solidification process begins at the boundary, like, or at the surface of the mold cavity here. It begins. So then, after some time, you are going to pour down the liquid metal by inverting the mold box, so that all the excess metal, liquid metal, will fall down. Okay, and it is collected here. Again, this collected material is we are going to remelt it, reheat it, and then we are going to use for the next operation. So like that. Now what is happening? Again, after pouring down completely the liquid metal, bring it to the upright position. Bring it to the upright position, so that wait for some time. All the liquid metal properly solidifies. There won't be any more liquid metal. So then, the gases will escape through all this porosity what is there in the mold cavity. Then after complete solidification is over, then what we will do, we will separate out the left and right portions of the mold. See here, this is from the center. You can see the left portion is different and right portion is different. We can separate them out so that we can take out the product which is required. So this is the shape of the product. The entire inside it is hollow. Okay, like this we can produce the casting. This type of casting is called as slush casting. Okay. So now this is the with the diagram. I have explained all these things. Same thing, step by step explanations is given. You can see slush casting, how it is done. Castings with external features having aesthetic value are made by this technique. Okay. Castings will be hollow inside and wall thickness may be non-uniform. Sometimes may be uniform because there is no rotation, there is no something like that. In the previous case, we have seen that the centrifugal force rotation is there. Because of rotation, what happens? Normally, uniform wall thickness will be getting. But here there is no rotation. So we are just filling the liquid metal and pouring down the liquid metal. Some places may be some metal thickness may be more, some especially at the bottom. Like that it happens. Maybe uneven surfaces also possible. Okay. Then core is not required for the purpose. Example, it is given what type of products are produced. Lamp posts, hollow tubes, lamp posts. They are produced like this. Statues. Inside of the statue it is completely hollow. Okay. So only the outer surface you can see. Statues, Buddha statue or any other statue you might have seen. So statues, toys, etc. are produced by this method. How it is produced means molten metal is poured into the metal mold. Molten metal is poured into the metal mold. This is the metal mold. Okay. Then into this metal mold, the molten metal is poured. After spraying the non-sticky powder or totally treating this surface. It should not, the liquid metal should not stick. After the solidification, it should be easy to separate. Like that, we have to coat this. Coating of the surface to be done. After coating is done, then molten metal is poured into the metal mold. After a few seconds, the mold is inverted and the molten metal is drained out into a container. This is the container. The remaining excess liquid metal will be drained out or it is collected in the container. Okay. Then a thin layer of solidified metal is formed in the mold. Here, thin layer is formed here. Okay. And it is going to be solidified. Now, after that, the mold is opened. Now it is in the closed condition. The mold is opened and the casting is taken out. This is the required casting. So this is the slush casting. Okay, simple method to make this hollow shaped component or product. This is called as hollow casting. So normally used for making the statues and other. But inside it is rough. Inside it is rough and non-uniform. So therefore, it is that is this slush casting. The mold is opened and the thin layer hollow casting is taken out. Inside of this, outside the finish is good, okay, because this is completely surface is good, smooth surface is there. You will get the outer surface smooth. But inner surface, what happens? There is no machining activity inside. Inside we cannot machine. We cannot remove the excess material or something like that. So inside it will be usually rough surface, and sometimes some areas it is over coated, some areas less thickness, like that it will be there. So that is a thick, slush casting. Next, last type of casting here we are going to study in this chapter is thixo casting. Thixo casting, Rio casting. What is the meaning of that thixo casting? Thixo casting means, you know, anything you heard about thixotropy? ಕೇಳಿದ್ರೇನಪ್ಪ? Thixotropy.
No, sir.
Thixofluids
No, sir.
ಅಂತ ಕೇಳಿದಿರ? Rio fluids and rheology, which comes in fluid mechanics. Rheological fluids ಅಂತ ಬರುತ್ತೆ. Newtonian fluids, non-Newtonian fluids, ಇದೆಲ್ಲ ಗೊತ್ತಿದೆ ತಾನೆ?
Yes, sir. Yes, sir. Newtonian and non-Newtonian. Yes, sir.
Newtonian, non-Newtonian fluids ಎಲ್ಲ ಗೊತ್ತಿದೆ ನಿಮ್ಗೆ ಅಲ್ವಾ? ಸೊ ಏನು ನ್ಯೂಟೋನಿಯನ್ ಫ್ಲೂಯಿಡ್ ಅಂದ್ರೇನು, ನಾನ್ ನ್ಯೂಟೋನಿಯನ್ ಫ್ಲೂಯಿಡ್ ಅಂದ್ರೇನು, ಯಾರು ಹೇಳ್ತೀರಾ?
Sir, Newtonian fluid means the fluid which obeys Newton's law.
Which obeys Newton's law of fluid flow. Okay.
Yes,
Other Newtonian fluid. Non-Newtonian means which do not obey the Newton's law.
Yes, sir. Yes, sir.
Which do not obey the non-Newtonian. So some fluids, that is usually the general fluids what we are studying here. In rheological fluids, one more rheology, it is there. There is a branch. There is a branch of fluid mechanics, rheology. Okay. I think somewhere in the last chapter you will study fluid mechanics, rheological fluids. For example, if you flow of a slurry, you know what is slurry? Slurry andre gotthenappa? Do you know what is slurry? Yararu obru heli, yes or no?
Sure.
Nikhil Raj, what is slurry?
Yes, sir.
What is slurry?
Yes, no, sir. It is a mixture of solids. It is a mixture of all solids which is having density more than the water.
Yes. So the slurry nothing but it is not pure liquid. Okay. Some solid particles are also present with the fluid. Okay. So then what happens? It becomes slurry. For example, when it rains heavily, especially where the bare land without any grass or something, into the mud particles, mud, stone, everything, small stones, mud, everything mixes with the rainwater and it flows in the stream. Okay. Water also, pure water also, clear water which flows in the river and channel, whatever it is, that is also there. And the other type is mud water also flows with that, isn't it? That mud water contains so many solid substances with it. So that is almost slurry, but still it is not a very perfect slurry type. If you compare, and then if you see, you might have seen Bangalore urban area, you might have seen the drainage, big, very big drainages you might have seen. There, all municipal waste mixed with water, it is flowing in the channel, big channel. Okay. Kannadadalli mori anta kariteve. So that big channel which is carrying the water, it is not only pure water, it is that water is contaminated, it is mixed with all type of solid debris and solid substances. So that is no way following the Newton's law of motion. It is almost slurry type. And for example, you might have seen slurry, the cement concrete. When some very big building, apartments, etc., being while laying the roof, while building construction, roof laying, concrete hakbekadre ಮಾಡ್ತೀವಿ, from bottom there is a machine to push the slurry. We prepare the slurry of concrete by using water, cement, pebble, and so many things we mix, sand, everything, so in different proportions, and then that will be pushed to by using a heavy capacity compressing machine, so that that pump is used, slurry pump, that is not water pump, slurry pump itself is used. That pump lifts the slurry of that concrete to the top floor wherever they are laying the concrete. So then it is pushing the slurry. Absolute example is slurry, that there you can see. Okay, so these things, study on these things is called as rheology. It is not pure fluid. The solid components are mixed with it. That is the rheological fluid. Okay, study on those properties, those flow characters, everything is called as rheological study. Okay, that study itself is called as rheology. So those fluids, like here also, the liquid metal, it is not pure liquid now. We are going to convert it into transient state. It is neither solid nor liquid metal. In between state, it is called as slurry. Slurry nothing but neither liquid, pure liquid, nor completely solid. It lies in between. So that state of fluid, that state of matter is called as slurry here. So that slurry is called as rheo. That is rheo or rheology, etc. So that is that another term we use, we call it as Thixo casting process. So now here what is happening, the partial solidification, there is a container here, you can see the partial solidification of the material. It is done, partial solidification. So this partially solidified metal is taken into a state, into a die, and then there it is squeezed. Yesterday in the example squeeze casting, where it is squeeze casting, we have seen that molten metal is poured, and then that molten metal is pressurized like that, and then here we are pouring the molten metal itself, and afterwards it is squeezed after it becomes solid, partially solid. Like that, here also what is happening, here also we are melting into the partial state only, not fully liquid. Okay, that partial liquid or slurry is taken into this, and then it is compressed into the required shape. Okay, this technique of producing the castings is called as the rheo casting or Thixo casting. Okay, see here it is also called as forging operation, because almost it becomes, by the time you compress, it becomes solid. So then you are pressing the solid itself. So like that, it is also called as forging operation or Thixo forging. It is also called as. See here, one is partial solidification. That partial solid material, it is taken, and that is slurry is taken. That is called as rheo casting. In the rheo casting, we are taking the partially liquid metal, and then we are pressing it like squeeze casting. What we are doing, we are performing the squeezing operation. See, the liquid metal is poured into it, not fully liquid, partial liquid, and there is a pressurizing mechanism here that pressurizes. So this is the mold cavity. This is the mold cavity, so that we are getting the shape of this product when it is forced into this. Okay, that is rheo casting. And Thixo casting means, see, this metal solidify, it has just become solid. Then here it is a billet with special grains, spherical grains. Billet nothing but immediate the shape of the casting, what we are getting immediately, either square shape or cube shape. Normally cubic shape structure, we call it as billet. Okay, that billet with spherical grains. Grains means the which is the within the solid metal, the grains are formed during solidification process. So those grains are in this spherical shape. It means that they are undeformed shape. Undeformed shape. That shape is called as the spherical shape. Okay, the grains are in spherical shape. Then this solid metal is reheated to semi-solid globular feedstock. So totally this solid material we are reheating to become a semi-solid. Then what we are doing, that semi-solid material, it is pressurized. See, that material is kept here and then pressurized and a stock is obtained. Finally the product of required shape is obtained here. So you need not have to explain both the lines. So this is the either the billet with the spheric. You can start from here, this okay, and then reheating, and you can explain this, or melting the furnace, melting the metal into the partially liquid and forging it. This process you can explain or draw this full diagram, no issue. Okay, so this is called as Rio casting or the fixer. Rio nothing but it is this movement of flow of slurry simply. So that is called as the Rio casting. Okay. So in this process, semi-solid metal is subjected to compressive force inside a die. Where is the die? This is the die, and this is the semi-solid material. This is the compression force applied. So then it will flow into it, and then required shape is produced. So how it is done? A known quantity of metal is heated in a furnace to its softening temperature. Then subject to external force when kept inside a die cavity. Since this metal is subjected to squeezing action, it is when it is in the plastic state. This state of the material is called as plastic state. What is the plastic state? Means when the metal is at the room condition, room temperature, it is at solid condition, solid state. Then when you start heating the metal up to certain temperature, it becomes very red hot, completely red condition, red color. So the metal turns to red. So then it is plastic heat. That state is called as plastic state. Okay. So that is up to the plastic state or semi-solid state, both are same. It is heated, then it is called as thixocasting. It is just squeezing, compressive force is applied on the semi-solid material, that is called as the thixocasting. So this is the steps are given. The metal pieces are kept in the furnace and maintained to known temperature. When the metal reaches to a pasty zone, it is transferred into the cavity and forced between two dies. The dies used for the purpose are capable of withstanding wear and tear. Here more and more wear and tear is possible in this case compared to liquid metal. By using of pure liquid metal, here use of semi-solid material or semi-liquid material, the wear and tear of the component or die is maximum. So therefore we have to use the dies which are capable of withstanding that much wear and tear. Okay. The semi-solid metals cools very fast and gets solidified. The component is withdrawn and casting is ejected from the figure as shown. So like that the product is manufactured. So this is called as thixocasting and this is called as slush casting. So both of these process we have seen today. So any discussion in the entire module 2, you can have a discussion now. Okay. ಯಾರಿಗಾದ್ರೂ ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಕೇಳಿ, we will discuss on it. ಈಗ ನಾನು ಇದುವರೆಗೆ ಸುಮಾರು ಟಾಪಿಕ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. ವಾಟ್ ಡೌಟ್ಸ್ ಯು ಹ್ಯಾವ್, ಎನಿ ಕ್ವೆಶನ್ಸ್ ಯು ಹ್ಯಾವ್, ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ನೌ. ಏನ್ರಪ್ಪ?
ಸರ್,
ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ಕ್ಯಾಸ್ಟಿಂಗ್ ಎಲ್ಲ ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಓಕೆ.
ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತದೆ ಸರ್.
ಏನಪ್ಪ ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತಾ ಇದೆಯಾ? ಇಲ್ಲ, ನಾನೇನು just I asked any doubts are there, anything to clarify like that. If you have anything you can discuss with now. ಯಾಕೆಂತಂದ್ರೆ I have finished these 2 chapters. Otherwise I cannot go to the next chapter now. Next chapter from tomorrow onwards, next class onwards. There it is the continuation of once again casting process, where we are studying about the defects in casting, etc. Okay. 11:35. Anything is there? Still 20 minutes time we have. Once, otherwise I will play one casting video. You can observe that casting video once again. I had shown that in the beginning. Once again I will show how the castings are done.
The sand casting process is a popular method to produce shaped parts weighing from less than a pound to several thousand pounds. The process is versatile, constant, even because of low tooling costs. Doing any part configuration that can be made using another casting process, including those with internal passing footing, can be reduced to a pattern created as a sand casting. To begin, a pattern of the desired finished part, including the metal delivery system of gates and risers, is constructed out of wood, urethane, metal, or bone. Sand, which contains a bonding material to hold its shape, is packed around the pattern.
The patterns were kept.
Sand, leaving a cavity in the mold that is the shape of the part. Molten metal is poured into the cavity and the metal solidifies. Sand is removed through a shakeout process. Attachments, including the metal delivery system, are trimmed, leaving the desired part. As an alternative to creating a physical pattern, many customers take advantage of metal patternless molding. Using this technology, the reverse of the casting is machined from sand or other materials to create the mold. Production then proceeds normally. Timing is quicker, design changes are easier, and hard patterns do not need to be stored or maintained. To learn more about this process, or to determine if it's a good fit for your application, give us a call or go to metaltech.com. Metaltech International, because you demand more than metal. Yes, lots of people, when they were younger, went to the beach and made sandcastles. First of all, you need a bucket, and the first thing you do after mum and dad have brought you that is run onto the beach and try and make the sandcastle as quickly as you can. When you first go on the beach, you're up a long way from where the sea has been, and the sand is very dry. It doesn't really make very good sandcastles because it just pours almost like a liquid. So after a while, you run down by the sea where the waves are coming up and you try again. But that sand is too wet and you find that it sticks to the side of the bucket. But between the two sides of the beach, you'll find the sand that's just right, where it's bound together with water so that it will form a perfect sandcastle. They always have a slope on the sides. The reason for that is once you've filled it, you give it the custom couple of pats, that releases the bucket, and then it will lift cleanly off the sand. Rather than using water to bind the sand together, this sand is bound with oil so that it will bind together and hold the shape really well. using oil means that we can use a finer grade of sand, which will give a better quality of casting. We're going to make our sand mould in a metal box known as a flask. This is a two-part box which has locating pins so that they can be taken apart and locate accurately each time. The top is known as the cope, the bottom is known as the drag. Today we're going to make two products. The first one is a small cylinder or bearing block, and we'll use sand moulding to produce that. The second product is a small coin, a supermarket trolley, so that you don't have to leave your pound in at the supermarket. To make a simple object, such as this little number plate, it's quite easy to just make it as a one-part pattern, which can easily be produced and removed from the sand. It does have sloping sides, it has the draft angle, just like the slope on your sand casting bucket. Some more complex shapes are difficult to take out of the sand. Even a simple cylinder, once you've buried it in the sand, you wouldn't be able to remove it. They're painted black because that's a visual clue to the people in the foundry that they know they've got to add a core to the mould. So if we take the cope off the top of the flask and set that to one side and turn over the drag, we often refer to that as an inverted drag, and add the first part of the pattern. One side has locating pins, so it sits flat. We'll use the side with the holes face down in the moulding box. This is being set so that nothing touches the sides of the moulding box, and there's a space in the corner for us to complete the moulding work. We give a quick sprinkle of parting powder, and it's just used to help remove the pattern from the sand when we're opening the mould. Because the sand has oil, you may want to wear gloves to protect your hands or use a barrier cream, particularly if you're using reclaimed second-hand sand. We start off by sprinkling the sand, breaking it up as we go, just like making a presses down. We now need a wooden pin known as a sprue pin, and I place it in the corner of the box. If it touches the pattern, it will damage the outcome. If it touches the flask, the heat from the molten metal will sink out and it will start to solidify before it has completed the task. We repeat the process. Mary Berry would be proud of me doing around the pouring hole to make sure there's no leak. And we can split the two halves of the flask. The patterns now need to be taken out. That can be done just by giving them a gentle tap and then lifting the pattern cleanly out. We've got a good impression in the sand. The same with the other half. That's come out quite well. There's a little bit of looseness there. Nothing to worry about, that can be repaired. So that is the basic mould produced. We just lay across the prints. The two halves go together. Again, just checking for loose sand. Locate a pin, put it together, and that's ready for pouring. Because we're going to be using molten metal, we better have a bit of health and safety going on. During the break of 5 to 10 minutes, we now have a pot of molten metal. I'll just turn the burner off. Nice long tongs, so that I'm well away from the heat. Just rest it, move the tongs down, and then pour the metal into the pouring basin so that it gently flows. The top of the metal is slightly convex when you first pour it, but as things cool down, the casting contracts, the metal will feed in, and we'll see. Because we've only used a low temperature metal, the sand hasn't really been compromised. We can now break out nicely aligned on the joints. We just have to cut the sprue off, and that can be remelted for the next job. There's very little waste in the foundry industry. And the other, in this case, has got a little shopping trolley load result. Right.